To a quadratic formula, and you've seen this before, right? So they may get you to memorize this, something like that, okay? Essentially, a quadratic formula, a lot of people forget, is solving for a value of x, okay? Specifically, it's solving when it's equal to a certain value. Normally, when you use quadratic formula, we are looking for x-intercepts, so points when we cross the x-axis, right? So we'll kind of put a makeshift graph here. If I'm looking for x-intercepts, okay, I would set this equation, our f at x, that's when y is equal to 0, when we're looking for x-intercepts, okay? Now, I can quickly tell the a value of this is a positive 2, so assuming that this actually has x-intercepts, probably looks like something like this. Now, there are possibilities that we get quadratics that have no x-intercepts, okay? Or maybe even quadratics that only have one x-intercept. And as we go through this, I'll just briefly touch on those, okay? Here are our numbers. That's our A, our B, and our C. So technically there are 3 forms to quadratics, right? This is what form? Do you remember? What's this called, this form? This is an S. Yeah, that's right. This is a standard form. And when we're talking about the quadratic formula, we refer to the standard form. If we're given something in vertex or factored, we actually have to put it into our standard form before we can apply the quadratic formula. Okay, so always keep that in mind. We refer to that. Now, plugging it in isn't that hard. As long as we remember the formula, we just plug things in. So here I have negative 5 as a b value. So I have subtract negative 5, or negative. Exactly, yeah. That'll become a positive 5. Plus or minus, and I'll talk about why it's plus or minus. Our b is negative 5 again, squared, minus 4 times our a value, which was 2, and our c value, which was negative 1. Good. And all of that will be divided by, okay? So in other words, we have to equate everything on top before we do 2, or divide by 2 times the value of 2, right? A, it's actually 2a. Okay, so then we can just go to a bit of computing here. This becomes positive 5 plus or minus the root of, and what is 5 squared going to be? Or negative 5 squared? And I'm going to do, now technically these are 3 numbers multiplied by each other, and think of this like a negative 4 when multiplying, okay? So to make things simple for myself, I'm going to do negative 4 times negative 1 first. In multiplication, it doesn't matter what order we multiply in, okay? So negative 4 times negative 1 is going to give us positive 4, times 2 is 8. So in other words, plus 8, okay? And again, all divided by 2 times 2, which is 4. This will be the square root of 33. So 5 plus or minus square root of 33. Okay. Now, I've gotten the value of 33 here. Very important, okay? What this tells me, A, because it's positive, I'm going to have 2 values. Or, sorry, I wrote x because we're discussing x-intercepts, but in general, it doesn't always have to be an x-intercept. We're going to get 2 values as our answers, okay? If I got a square root of a value of 0, then I'd actually get 1 value. And if I had a negative square root, okay, there would be 0 values. And in this case, that would mean there'd be no x-intercepts. So 0 values refers to something like this, where the vertex is above the x-axis and it's facing upwards. Okay, that's for x-intercepts. 1 would mean the vertex is right on the x-axis, and the one we're talking about is going to go through it twice. Okay, so just keep that in mind. So we have plus, and the reason they have plus or minus is because when we square root something, we get 2 answers. So we're going to split our equation now. Just like when we're factoring, sometimes we have to split the equation. We're going to get x, and remember this is x is equal to, right? 5 plus the root of 33 divided by 4, and 5 minus the root of 33 divided by 4. We'll try to do this all in one step. The next part, I'll get a calculator out. 33 rooted plus 5 divided by 4, 2.68. So a positive value. And in the other one, calculator, 33 rooted minus 5 divided by 4. Is that right? Oh no, it wasn't minus 5. I screwed that up. Sorry. It's 5 minus 33 square rooted. Gives us a negative value, okay, divided by 4. We always got to make sure we do things in the proper order. Negative 0.18. Okay, so x is equal to negative 0.18. So remember when we didn't really factor values, we'd say it's unfactorable. That's not always the case. It's just sometimes they're decimals, right? And true, there are some that are unfactorable when we'd have like 0 values. But here, we just wouldn't be able to factor to find these decimals. It'd be very tedious to go out about it the way we factor, so we use quadratic formula. So in other words, if we were to graph this, our x-intercepts, one is at negative 0.18, and the other is at 2.68. Okay, and we have some parabola that goes up and through those 2 points.